Question 7, part A and B, are the common ion effect, which is Le Chatelier's principle applied to solubility equilibrium. So on these, just like others, we want to think about what's being dissolved. We want to be able to turn that into a KSP. And very often, thinking of it in terms of a Rice table is very valuable. So we're getting 1 calcium for every 2 fluorines. So we've got my X and my 2X. The 2 also becomes an exponent down here. But what is different, or what is the Le Chatelier's principle part of this, is we're kind of adding in some fluorine where we already have an initial concentration of one of our ions that came from another solution. So there's already fluoride there, although there's no calcium. That's going to impact how much the calcium fluoride can dissolve. So we still have our X and our 2X. And one thing that we do estimation-wise here that makes the math easier, once again, we're not going to have to deal with quadratics in this. In this case, we probably wouldn't have to either way. I haven't done the math that way. But the idea is the amount that we already have is usually significantly larger than the amount that will dissolve. So we actually estimate this over to say, well, even though I'm going to dissolve a tiny bit more, I'm treating it as if the fluoride that came from the sodium fluoride is all or most of it. So then when I bring that down here, I do have a certain amount of X that can dissolve, which is my calcium. I'm not doing the plus 2X here because there will be so little impact or change from that. So then when I'm going to through all of my steps here, I square that, I still have the X. So then when I divide over, I get that my X is very, very small, 6.4 times 10 to the negative 8. Rather than the, quote, normal amount of calcium and fluoride that can dissolve, much less can dissolve because I have to have that same KSP, I have to have the same equilibrium constant, and there's already so much of one of my ions or my products in solution.